Good day, everyone. Welcome to Calcumind. Today, we are going to be treating statistics, under which we'll be touching probability. So, for our question today, we'll be looking at a probability pass question, which says, in a shooting test, the probability of hitting the target is 1 over 2 for A, 2 over 3 for B, and 3 over 4 for C. If all of them fire at the target, find the probability that at least one of them hits the target. So first off, we're going to outline the parameters that we've been given. So for our question, we've been told that the probability of A is equal to 1 over 2. The probability of B is equal to 2 over 3. And the probability of C is equal to 3 over 4. And we're told to find the probability that at least one of them hits the target. Now, because we've been told at least one of them, it means that it could be that A hits the target, or B hits the target, or C hits the target, or A and B hits the target, or B and C hits the target, or A and C hit the target, or A, B, and C hits the target. Now, we're going to approach this in 3 ways. The first being to find the complement of each of these probabilities. So we're going to find the complement of A, the complement of B, and the complement of C. So diving right into that, we have that the probability of A complement or A prime is equal to, as we recall for the formula for finding complement, it is 1 minus the probability of A. This is equal to 1 minus 1 over 2, which is equal to 1 over 2. Next, we find the complement of B. So we have that the probability of B complement equals 1 minus the probability of B, which equals 1 minus 2 over 3, which is equal to 1 over 3. For the probability of C complement, we have that this is equal to 1 minus the probability of C. This will be equal to 1 minus 3 over 4, which is equal to 1 over 4. Okay, since we found the complement of the events A, B, and C, our next step is going to find the probability of none of them hitting the target. So we have that the probability of A, and we have the probability of A prime. We have the probability of B, and the probability of B prime. And we have the probability of C, and the probability of C prime. Now we've gotten the complements for A, B, and C. What we're going to find next is the probability that none hits, which is equal to the probability of A prime intersection B prime intersection C prime. Now we are going to make an important assumption in order to continue. And that assumption is that A, B, and C are independent events. Now, if we recall what independent events are events that can occur simultaneously or side by side without affecting each other. For example, you can toss a coin rather, roll a die, and roll another die, each at the same time, without either of those events affecting the outcome of each other. So now, we are going to find the probability of non-hits, and we've said that it is equal to this, and we are taking an important assumption that these 3 events are independent. Now, because the events are independent, the probability of the intersection between A prime, B prime, and C prime will be equal to the probability of A prime multiplied by the probability of B prime and multiplied by the probability of C prime. Now, this is going to be equal to our value for the probability of A prime, which is equal to 1 over 2, multiplied by the probability of B prime, which is 1 over 3, multiplied by the probability of C prime, which is 1 over 4. So all of this is equal to 1 over 3 times 4 is 12, 12 times 2 is 24. So the probability that none hits is equal to 1 over 2, 24. But recall, what we are looking for is the probability that either of them hits the target. Now, since we found the probability that none hits the target, we simply find the complement in order to get the probability of any one of them hitting the target. So since we found this, we can say that the probability of any hitting the target is equal to 1 minus the probability of none hits the target, which is 1 over 24. Therefore, the probability that any of them hits the target is equal to 23 over 24. Thank you very much. Please, if you've enjoyed the video, do well to smash that subscribe button and like and share.